Welcome back to our channel. Welcome back to Science Modernizers. So today we are going to solve question on state registered nurses, midwives and health technicians concours 2022 in Cameroon. So we are going to begin with the mathematics session 2022 session. So the questions are displayed on the screen. So the instructions are the candidates must answer the questions in the language of his choice. So basically the questions come in both English and French. So if you're francophone, you get it in French, you answer in the French section, and if you're an anglophone, you answer the English section. So if you make any mistake, put a cross on the incorrect choice and circle the correct answer. But it is always advisable for you to cross-check everything before you take an answer. Okay, so we are going to begin with the very first session, which says, the very first question, which says, the function f defined on R different from 2 by f of x is equal to negative 2x squared plus x plus 1 divided by x minus 2 can still be written as f of x is equal to ax plus b plus c divided by x minus 2, with a, b and c three real numbers having values a, b, c, d, e. So we have to express f of x, which is given as negative 2x squared plus x plus 1 divided by x minus 2 in the form ax plus b plus c, and we are going to compare the coefficients with f of x in that form and definitely get the possible values of a, b and c. So in order for us to do this, it is easier for us to see the solution when we pass through Euclidean division. So we are going to take the Euclidean division of negative 2x squared plus x plus 1. So we are going to divide this by x minus 2. So we are simply going to pass through normal long division. So with long division, we see that negative 2x squared divided by x will definitely give us negative 2x. Now negative 2x times x will give us negative 2x squared. Negative 2x times negative 2 will give us positive 4x. So we simply subtract. So negative 2x squared minus 2x squared gives 0, and x minus 4 gives us negative 3x. Then we bring down 1. So negative 3x divided by x will be negative 3. Negative 3 times x gives negative 3x, and negative 3 times negative 2 gives positive 6. So we simply perform again the subtraction. Negative 3x minus 3x gives 0, and 1 minus 6 gives negative 5. So we see that this function, the function h of x, can definitely be written in the form negative 2x minus 3 plus negative 5 divided by x minus 2. Now if we compare this with the values of ax plus b, we see that a takes the place of negative 2, b takes the place of negative 3, and c takes the place of negative 5. So it means that the solutions of this equation, the possible values of a will definitely be a equal to negative 2, comma, b will be equal to negative 3, and c will be equal to negative 5. So going down to the choices, we clearly see that there is no option here which provides us with the possible values of a, b and c. So it means the correct answer will be no answer is true. We are going to proceed with the second question. The second question reads, the set of solution for the inequation, the natural logarithm of 2x plus 1 greater than or equal to the natural logarithm of x minus 3. So when solving logarithmic inequalities containing logarithmic functions, we have to be very careful with this type of functions. So the very first thing that we are supposed to do is to write down the domain of these functions. So if I call the function on the right hand side g of x, which is equal to the natural logarithm of 2x plus 1, and I call the domain on the right hand side f, let's say f of x, which is equal to the natural logarithm of x minus 3. So the first thing is I will have to define the domains, and we are going to look for the range of values for which this left hand side, the natural logarithm of 2x plus 1, is always greater than or equal to the natural logarithm of x minus 3. So let us write down the domain of g. So the domain of the function g, sorry about that, the domain of the function g will simply be such that we note that, let us recall that for the natural logarithmic functions, let's say we have the ln of x. For this function to be defined, x should be strictly positive, so we have to have that in mind. So in order for us to define the domain of our function g, it means we are definitely going to have to say that the function 2x plus 1 should strictly be positive. So this means x should strictly be greater than negative a half. And for the function f, it has a domain df such that x minus 3 should strictly be positive, and where we get that x should be strictly greater than 3. So the natural logarithm, the natural logarithm of 0 does not exist. So in order for us to solve this inequality, we have to take into consideration the domains of the function. Now, resolving this equation simply, I will definitely bring everything on one side of the equation and resolve easily. So it definitely means applying the natural logarithm, applying the laws of natural logarithms. That is, if I bring the natural logarithm of 2x plus 1 minus the natural logarithm of x minus 3 strictly greater than or equal to 0, I see that we can definitely apply the laws of logarithm. So this means I will have the natural logarithm of 2x plus 1 divided by x minus 3 greater than or equal to 0. So in order for us to solve this, we can take the Napier's number on both sides. So this means we have 2x plus 1 divided by x minus 3 divided by x minus 3 strictly greater than or equal to e raised to the power 0, which is equal to 1. So bringing everything on one side of the equation, I get 2x plus 1 divided by x minus 3 minus 1 is greater than or equal to 0. So simplifying, we get 2x plus 1 minus x plus 3, all of this divided by x minus 3 greater than or equal to 0. And now we clearly see that the denominator cannot be 0, so it cannot be 3, because 3 will definitely be a point where that function will not be defined. So simplifying, we will get 2x minus x gives us x, and 1 plus 3 gives us 4, divided by x minus 3 greater than or equal to 0. Now we'll go now for critical values. For critical values, we have the numerator. So we are going to take the critical values of the numerator. So we are going to have x plus 4 equal to 0. So this means x will be equal to negative 4. And for the denominator, we have x minus 3 is equal to 0. So this means x will be equal to positive 3. So we are going to represent these solutions on the number line, and you are not supposed to forget the domain of definition of your function. So I'm going to trace a number line in which we have our critical values. We have negative 4. Negative 4 can be included since it satisfies this equation, this particular inequality. Now the next is we have the point 3. 3 is not defined, so it is going to be excluded from the domain. So we are going to check the signs of our respective regions. So I'm going to use a different color to illustrate that. So we see that if we take any value between negative 4 and 3, we can take a point like 0 and we substitute in our inequality x plus 4 divided by x minus 3. We are going to get that if we put 0, we are going to have 4 divided by negative 3, which is negative. So it means this region will definitely be a negative region. Now from negative 4 downward, we can plug in any value inside that inequality. Let's say negative 10. If we take negative 10 plus 4 divided by negative 10 minus 3, so you see that we have negative 6 divided by negative 13. But this negative will simplify to positive, so it means that region will definitely be positive. So here will be positive. And if you take 3 and above, 3 plus a value a positive value plus another positive value, x plus 4 will be positive, and a value greater than 3 minus 3 will always be positive. So it means that set is that side is always positive. Now, is that the solution of the inequality? No. We have to take into consideration the domain of the function. Now, taking into consideration the domain of our functions, we saw that the domain of the right hand side was x strictly greater than negative a half. So negative a half can be located somewhere here on our number line. So here we have the point negative a half, and the other point was x strictly greater than 3. So if we have to represent the solution of the three systems, so we see that the solution of the first system is that we are looking for the region where x plus 4 divided by x minus 3 is positive. So it is definitely going to give this region. It's definitely going to give this region and this other region. So it means x will be less than negative 4, or x should be greater than 3. But does this satisfy our initial inequality? No. If we take a value, let's say a value like negative 5, and we replace inside this inequality, so what we get here is, if we are going to have the natural logarithm of negative 5 times 2 will give us negative 10 plus 1, that will be negative 9. We can already end here knowing that the natural logarithm of a negative number does not exist, so this is undefined. So that is undefined because it does not exist. Okay, so we are going to use that basis in order for us to establish something here. So what we are going to do is we have x greater than half, and we have the other point which was x greater than 3. So we are going to take where these two domains are definitely going to intersect. So x greater than half is all of this region on the number line. So it is going to be all of this. So we see that the point of intersection of x greater than half and x greater than half, x greater than 3, and the values and the interval which we had, negative 4 and 3, the point of intersection will simply be from 3 going upwards. So it definitely means that the possible values that we can get, or the possible solution to this inequality, will simply be all values of x which are simply greater than 3. So it means that the function, the initial function, cannot be defined at this point, but it is defined only in this domain. And in interval form, we can represent x greater than 3 as x belonging in the interval 3, which is excluded from the domain right up to positive infinity. So that is the set of solution. So looking into the options, we clearly see that the correct option here is option B. Okay, so going on to the third question. The third question says, given the equation defined on the interval which you are seeing by f of x is equal to 1 minus ln x into 2 plus ln x, where ln designates the natural logarithm, the calculation of the derivative of f is, so we are asked to get the derivative of the function. So we have to recall the product rule. So we know that if we have a function y which is a product of two other functions u, v, then y prime denoted as dy on dx is given by u times dv on dx plus v times du on dx. Are we there? So it definitely means in order for us to get the derivative of that function, so we are going to let our u to be 1 minus ln x and our v to be equal to 2 plus ln x. So it means the derivative f prime of x will be equal to, we'll start by keeping one constant, we'll let one constant and differentiate the other. So we also have to recall that the derivative of the natural logarithmic functions, we have the derivative of the natural logarithmic function, that's n of x prime, is equal to 1 divided by x. And in general, if you have the natural logarithm of a function f of x, then its derivative, all of this prime, will definitely be equal to f prime of x divided by f of x. So we have to remind ourselves of that particular law of derivatives. So let's get started with the derivative of this function. So we get y is equal to that. So it means I'm going to take my f prime of x my f prime of x will be equal to, we'll keep 1 minus the natural logarithm of x constant. Then I will differentiate the other function. That's, I will differentiate 2 plus the natural logarithm of x, that's all of that prime. That will be plus, I will keep 2 plus the natural logarithm of x constant. Then I will differentiate the other function, which is 1 minus ln x, all of that prime. So simplifying this, I get this will be equal to, this will simply be equal to 1 minus ln x, 1 minus the natural logarithm of x, now not be times. Now the derivative of 2 is 0 and the derivative of ln x is 1 over x. So we have that. That will be plus 2 plus ln x. The derivative of 1 is 0 and the derivative of ln x is negative 1 on x. So here we have negative 1 divided by x because of that negative in front. So if we expand the bracket, I'm going to have 1 on x minus ln x on x plus, that will be minus 2 on x, minus 2 on x, minus ln x on x. So 1 on x minus 2 on x, this is going to give us negative 1 all over x minus ln x on x minus ln x on x will be negative 2 ln x divided by x. So we can factor out negative 1 all over x into 1 plus 2 times the natural logarithm of x. So let's verify the option. So it means the correct option there will definitely be option B. Okay, so we are going straight to the fourth question. So the fourth question reads, the number of permutation of n elements of the bijection again from a set with n elements to an equipotential set is equal to, so that's definitely the definition of the factorial, of the n factorial function. So the correct option will simply be option A. And we all know that n factorial, is equal to n into n minus 1 into n minus 2, blah blah blah, right up to 2 times 1. So that is the definition of n factorial. 3 factorial is equal to 3 times 2 times 1. 4 factorial will be 4 times 3 times 2 times 1. So the correct option there is option A. So we are going to go to the next question. The next one says, in a box there are 10 colored stones, 3 white, 2 yellow, 2 green and 3 black. By randomly extracting a stone, what is the probability that it is white or black? So we have a bag. That bag contains 10 colored balls, so the sample space is 10. So we have 3 white balls, we have 2 yellow balls, we have 2 green balls, and we have 3 black balls. Now we are going to notice that these 2 events are independent events. Now the question says, by randomly extracting a stone, what is the probability that it is white or black? So the chances that we are going to pick a white ball or a white stone or a black stone will definitely be equal to. So it's since these 2 events are independent events, the probability of W union B will simply be equal to the sum of their respective probabilities. That's P of W plus P of B. So those are the chances that I can pick a white or a black stone. If they were independent events and we set the probability of picking a white and, that is maybe after 2 successive picks, then P of A intersection B is equal to P of A times P of B. So we get that the probability that we can pick a white ball will simply be equal to 3 out of 10, because there are 3 white balls inside the bag out of 10, plus the probability that we are going to pick a black ball. How many black balls are inside the bag? There are 3 black balls, divided by 10. So when we sum the two, we have 6 all over 10, which can be simplified to 3 all over 5. So it means the correct option is no answer is true. Answer is C. Okay, so we are going to proceed with question 6. So question 6 reads the sequence un defined for all n by un is equal to n divided by e to the n plus 1. The sequence un is A, divergent, B, not, C, convergent, and divergent, D, convergent. Okay, so we are going to recall some little theorems. Now, we know that for a sequence to converge, then the limit of that sequence should be finite. So it means the limit as n approaches positive infinity of the sequence, let's say an, if it is finite, then this sequence an converges. If the limit as n approaches positive infinity of an does not exist, or in other words can be plus or minus infinity, then we can say an diverges. Does not exist. Okay, then an diverges. So it definitely means we can evaluate the limit of that sequence. If the limit gives us a finite number which belongs in the set of whole numbers, then we can conclude that the limit converges. Also, we have to note that absolute convergence implies that the limit converges to a point. So if the limit as n approaches positive infinity of the absolute value of an converges, I'll use a stroke, converges to L, then the limit as n approaches positive infinity of an also converges to L. So those are properties of limits. So let's get started with the question. So we have to test if that sequence un is convergent or divergent. So we are going to evaluate the limit as n approaches positive infinity of un. Un is given by an. Un is given by n divided by e to the power n plus 1 as displayed on the screen. So we get, now by asymptotic comparison, we see that the function e to the power n plus 1 is far greater at positive infinity than the function n. So this means that the function n divided by e raised to the power n plus 1 is far less at positive infinity than 1. Now asymptotically, we see that this function e to the power n goes faster to positive infinity compared to the function n, and this can also be verified graphically, and so we can conclude that the limit as n approaches positive infinity of n divided by e raised to the power n plus 1 is equal to 0, and this is also equal to the limit of un as n approaches positive infinity of un. So definitely we see that the limit converges to 0. So since the limit is finite, it means the correct option is D. The limit is a convergent sequence. So the sequence is the convergent sequence. So that's the correct option. Okay, so now we are going to proceed with question 7. It says the set of solution of the equation of the inequation, we have the square root of x minus 1, less than, strictly less than 3 minus x is, so we have to look for the possible values of the range of values for which this is satisfied. So the first thing that we have to do, I will repeat again, is the domain of this function. So the square root function is defined only when the input is positive. So it definitely means we have x minus 1 should be greater than or equal to 0. So this means the function, x should be greater than or equal to 1, since the square root function is defined only for positive values. Now, in order for us to solve this inequality, we have to be very careful, because to square both sides of an inequality, it entails that both sides of that inequality should be positive. Now we have 3 minus x on the right hand side. Under which conditions will 3 minus x be positive? So we have to get that particular condition. So if we solve the inequalities, under which condition can 3 minus x be positive? We get that 3 should be strictly greater than x, or in other words, x is less than 3. So that's what it means. So with these conditions placed, or with these conditions in place, we can now square both sides of that inequality. Now squaring both sides of the inequality, we get x minus 1 is less than 3 minus x, all of these raised to the power 2. And this means I get x minus 1 less than, let's expand that, I have 9 minus 6x plus x raised to the power 2. And so rearranging this equation, that is bringing everything from this side right onto this side, so we get that we have x squared minus 6x plus 9 minus x plus 1 is strictly positive. So if we rearrange, we get x squared minus 7x plus 10 strictly positive. And so in order for us to solve this, we are going to pass through the method of factorization. So we are going to look for two numbers that when we multiply we have 10, and when we add we have negative 7, and clearly those two numbers are negative 5 and negative 2. So it means our equation will simply be x minus 2 into x minus 5 strictly greater than 0. Now we are going to take critical values. For critical values, we have x minus 2 is equal to 0, or x minus 5 is equal to 0. So we get either x is equal to 2 or x is equal to 5. So representing these solutions on a number line, we get this. We have the point 2 and we have the point 5. They are exclusive. So the next thing we do is we are going to test the signs. So if I take values between 2 and 5, let's say 3, and I plug inside this inequality x minus 2 into x minus 5 inside this inequality, we get that if you put let's say example 3, and if I take 3 minus 2 is positive, 3 minus 5 is negative, so it means the sign of this inequality will be negative in this region, will be negative. I really apologize for the background noise, so please just be focused on the video in order to get what is happening. Thank you very much for understanding. And so the next part is from 5 and above. You see that if you plug 5 and above in that inequality, we are going to get things positive, and likewise 2 from below, we are also going to get positive. So it definitely tells us that the range of values for which this is satisfied will be for x strictly less than 2 or x strictly greater than 5. Now, will our inequality be satisfied for all these values of x? So let's take the range. What was the domain of our inequality? Remember, the domain was x strictly less than 3 for x to be positive on the right hand side, and x greater than or equal to 1. So we go on a line and we represent those 2 points. Here I have the point 1 is found somewhere here, and the point 3 is found somewhere here. Now we see that if we take a value, let's say like 4, and we represent inside this inequality, and we replace in this inequality, we clearly see that we are going to have the square root of 4 minus 1. So here we can have the radical of 4 minus 1 strictly less than 3 minus 4. So what we have here is 2. So we are going to have 2 less than negative 1. Impossible. A negative number is not greater than a positive number. So we see that the inequality fails already in that domain. It is undefined in that domain. So what we are going to have then is we have the range x greater than or equal to 1 and x strictly less than 3. So it means that we can now come and look for the possible regions where we can have the values of x for which these inequalities will be defined. So we clearly see that from 3 coming downwards, and we also have 1 3 going downwards, and we also have 1 moving upwards. So we see that this function will not be defined in the interval negative 2, 3. So it means the only region which can satisfy this inequality will be from 2 right up to 1, because we are going to observe an intersection between 2 and the point 1. Now let's verify if 1 inclusive can satisfy that equation. 1 inclusive, we have 1 minus 1 which is 0, and we have 3 minus 1 which is 2. It satisfies the inequality. So we clearly see that that is a possible value, so it is included. So we get that the possible values or the possible range of values in which our inequality can be satisfied is that x should lie in the interval 1 and 2. So that is, so 1 is included. Now for the point 2, we can always verify. If we take the point 2, we get that for the point 2, is it included or is it excluded? So we can definitely define that. So for the point 2, we have 2 minus 1 which is 1, and I have 3 minus 2 which is 1. But 1 is not greater than 1. So we definitely see that amongst the options that are given, there is no perfect answer. So option C was supposed to be x. It was supposed to be x less than or equal to 1, strictly less than 2. But there is no option like that. Those are options. So it means there is no answer to that problem. So with no answer to the problem, you are at least supposed to tick something. So the only thing which you can tick here would definitely be this option C. Would be option C. So the other options do not work. So at x equal to 1, only for x, only at the point x is equal to 1, that's option D. The point x is equal to 1, it satisfies, but that's not the only value which satisfies that inequality. We have several values in the range 1 and 2. So if you can take, for example, if you take a value 1.5, not 0.5, 1.5, so 3 minus 1.5, we get 3 minus 1.5, we get 1.5, and then we have 1.5 minus 1 is 0.5. So the square root of 0.5 is definitely smaller than 1.5. So we get that there are many values in the range 1, 2 which satisfies that equation. So the correct option there is no answer. But if you're in the hall, you tick option C. Okay, so we proceed with the 8th question. So they say, in a hospital center, 10 people work, including 7 men and 3 women. In this staff, we choose at random, take note, at random, 3 people to ensure the guard on the day of celebration. The probability that all the 3 are males is, so we have, these events are definitely independent events, and we see that if we are to pick 3 men out of 10, it means it's going to be without replacement. So the chances, we are going to let A to be the event that we are going to select a man. So the probability, so if you let A to be that event, sorry about that, if we let A to be the event, then the probability that we are going to select 3 men will be, you see that in the first selection, if we pick a man, or if you select a man, we see that we have 7 chances out of 10 to select a man. And if in the second selection, we see that out of the 7 men, 1 has already been selected. So how many are left? 6 out of how many? 9. So the last chance, if you have to select again a man, will be 5 on 8. So the and simply represents multiplication. So I have 7 on 10 times 6 on 9 times 5 on 8. So remember, we don't use calculators. So what's 7 times 6 times 5? So if you operate 7 times 6 times 5, you are going to have 210, since 6 times 5 is 30 and 30 times 7, another 7 times 3 is 21. So this gives you 210 divided by 90 times 8. 9 times 8 is 72, so you have 720. This simplifies. And now 3 divided by 3 can divide, so we see that 3 can divide 21 7 times, so we have 7 divided by 3 can go into 72 24 times. So what is the correct option? The correct option is option C. Okay, so solving question 9, the solution of the differential equation y prime minus 2y is equal to 0, which takes, we have y prime minus 2y is equal to 0. Y prime minus 2y is equal to 0. We have initial conditions, y is equal to 3 when x is equal to ln 1. So this equation, y prime can be written as dy divided by dx, which is equal to 2y. So we can separate variables, so we get dy divided by y is equal to 2 times dx. So we integrate both sides. My integral sign is funny. Okay, so the integral of dy and y will definitely give us the natural logarithm of y will be equal to 2x plus a constant of integration c. So we are going to use the initial conditions in order for us to get the value of the constant of integration. So this is going to be the natural logarithm of 3 will be equal to 2 times the natural logarithm of 1 plus c. But the natural logarithm of 1 is 0, so it means c will be equal to the natural logarithm of 3. So I'm going to replace that back into this equation. So it means I'm going to get the natural logarithm of y will be equal to the natural logarithm of x. Sorry, I'm going to have 2x plus the natural logarithm of 3. So making y the subject, I will take the Napier's number on both sides. So it means y will be equal to e raised to the power 2x plus ln 3. And this is the same as e raised to the power 2x times e raised to the power the natural logarithm of 3. But we know that e to the natural logarithm of a is equal to a. So it means, so y definitely be equal to 3 times e raised to the power 2x. So the correct option is A. Now number 10. The probability of a balanced die appearing during a roll is 0.25. The number of phases is, so a balanced die means we definitely have equal figures which appear on every phase. So if the probability P of A is equal to 0.25, which is equivalent to 1/4. So we see that we definitely have 4 phases, since we know that the probability for an event to occur is equal to the number of times that event can occur divided by the sample space. So the sample space is the number of phases, which is 4. So comparing them, you see that the correct option there is A. So we are going to end in this session with question 10. So in the next video, we are going to proceed with question 11 right up to question 20. Then we go into physics. Thanks very much for watching. Stay blessed. Please don't forget to like, share and subscribe.